Okay, here we go. Number 5. First thing I see is this problem looks ugly. I'm very scared. Right? I see a problem and I'm scared. Now, the reason why this is not a scary problem is because they told me, look here, what does this mean? Take the derivative. Okay, this scary problem was scary, but now if I take the derivative of an integral, we learned that the derivative of an integral, right? Let's say let's say t, x t dt, right? That just gets plugged in. So this is just x. We just plug it in. But careful here, remember that there's a 2 here. I see the problem already. There's a trick here, there's a 2 here. But let's go and just take the derivative. A derivative of y means we're going to take the derivative of this problem, 5 plus integral 2x e to the negative t squared dt. The derivative of 5, because we can separate it, d over dx of 5, plus the derivative of this integral, okay? 2x to e to the negative t squared dt. Now, this just becomes what? 0, so we don't need it anymore. And let's go ahead and plug it in. The derivative over here on my right is going to be, first thing, just to FYI, some of these look familiar, right? Some of these, huh? Some of these have a 2, some of these don't have a 2. I wonder why. It's because when we plug it in, we need to do chain rule. So e to the negative 2x squared times the derivative of 2x is going to be 2 for us. Okay? So I'm seeing that this is going to be e to the negative 4x squared. The 2 in the front, we have 2 possibilities here. Let's take a look here. Now, which of these would be it? So if I plug in 0 here, and plug in 1. Now, that's the next challenging part. Is it going to be this one or this one? Right? Which one is it? Now, we're going to go ahead and plug in y as 0 and see where that takes us. I mean, I'm just thinking this is what they want. Y is equal to 5 plus the integral between 2 and x is 0 first, e to the negative t squared dt. I see your problem.
Mr. Code, Dove is wanting you to let him in.
Oh, darn it. Thanks for reminding me. Okay, so the problem is this part over here. What happens to this guy here? Because that isn't an easy integral for us, is it?
Mr. Ko, wouldn't it be 1? Because if you plug in 1 where x is, it's basically the integral from 2 to 2, and that's nothing, so 0.
Okay, so you're saying if I plug in 1 up, oh yeah, so it's 2x, right? 2 times 1. And then that would be 0. You're right, that would be 0. E to the negative t squared dt, and this would be 0. Good catch. Yep, that saved us a lot of time. Okay. If I did put in the 0 here, though, this one would be, like, we would have to try to figure out what the integral is. I was trying to figure out what would make that 0, and I forgot there's a 2x here, which made me forget. You see, the trick was that if you see that was 1, and then you could say 2 times 1 is 2, then that would be 0. Good job. Good catch. Stupid, every one of these questions like have like this one like catch to it. Okay, good job. Okay, let's look at number 4. Next question up. Now this question here, whenever you see this limit as h approaches 0, and these guys almost look like twins. The only difference is that h, right? Only difference is that h between the front and back. This should remind you of our limit as h approaches 0 of f of x plus h minus f of x all over h. And hopefully this reminds you of slope. This is just the fancy way of saying slope. And instantaneous rate of slope, instantaneous rate of change, because the h value is going to 0, so it's a small difference, a slow tiny difference, which is instantaneous rate of change for us. So this is just the same as the derivative of cosine of x, and then we're going to plug in 3 pi over 2. Okay. Remember the other version of the derivative is limit as h approaches a of f of x, f of, x minus, whoops, it's f of x minus f of a over x minus a. That's our other version, okay? So we take the derivative of this, there'll be negative sine of x, right? That's what the derivative is. And then we're gonna plug in 3 pi over 2, negative sine of 3 pi over 2. Now, what's the sine of 3 pi over 2? I like looking at my unit circle. 3 pi over 2 is 1, 2, 3, way down here. The sine is the y value, 0, comma, negative 1. The y value is negative 1. So negative of negative 1 is 1. Okay. Brand, is that okay? Oh, sorry, Safir, is that okay?
Yeah.
Okay. What do you think was the hardest part? Just identifying that that was a derivative, or the unit circle part?
Yeah, I forgot that it was derivative of like the cosine 3 pi of
Mhm.
2, so I tried to do derivative of top and bottom, and then I got 0.
Got it. Yeah. And that, yeah, I see what you mean. Cool. Thank you. If you actually do the derivative of top and bottom, that could be L'Hopital's rule actually, because it would have been 0 over 0 here. Okay. And that would have worked too. Here we go. Let's look at number 14. Actually, no, let's go 8 and then we'll go to 14. Oh, should. Okay, so this question is our slope fields. Now the question is, for certain differential equations shown above, which of the following could be a specific solution for the differential equation? So which of these equations represents the slope field here? Okay, so which of these? Now, if I just draw one graph, if I just pick a graph, you can see that this graph kind of looks like it's heading this direction, right? So this looks like not e to the x, because e to the x shoots up. X squared is a parabola, so a parabola graph looks like this. Okay, so do you see how those for sure don't work? E to the negative, I don't know about e to the negative x yet. What about cosine of x? Cosine of x looks like this. That's what this graph looks like for cosine. Sure, this might be sine, right? Sine graphs look like this, and this could just be the beginning part, but it's not. And then natural log. So we have to remember what these other graphs look like. So first, let's look at the e to the x graph. What does e to the negative x graph look like? So if e to the x shoots up like this, if all your positive values become negative, the graph would actually go this other way. So that's I totally forgot what e to the x looks like. Remember, e is 2.7, blah, blah, blah. If I give that an exponent, that's like saying 2 to the x. As x gets bigger, that means the value is going to get bigger. So we shoot up this way. But as x gets smaller, 1 over 2, 1 over 4, 1 over 8, that gets smaller. So if I have to reteach myself how to graph these graphs, I'll do it, especially if it gives me a point and I don't waste that much time. Now, negative x, if you remember, if I just put a negative and exponent, it actually changes, it flips the graph in a mirror reflection across the y-axis, because all my positives become negatives now. So for sure, it's not this one. My only choice is this guy here. Wait, is it my only choice? We said nope, 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 because that should have started on top coming down, top coming down. So just by process of elimination, we have ln of x. Now, what does an ln of x graph look like? Well, let's create a table quickly in case you forget. Okay, so natural log of, what does natural log mean? This is log base e of x. So I wonder if you guys remember how to check it. Plug in easy logs that you know. First, what is the log base e of 1? What exponent of e will give you 1? 0. So when x is 1, y is 0. 1, 0-ish. Yeah, that's not bad. And then if I say the next value, so x is 1, y is 0. Next one is log base e of e. E to what exponent is e? That's 1. So if x is e, y is 1. So at 2 point something, 2 point something is way over here, y is 1. So we're taking up this pattern right here. That's natural log. In case you forget, logarithms, you create a table quickly and just plug in the logs you know. If I gave you the graph log base 2 of x, how would that graph look like? Creating a table quickly. Easiest log base 2 of 1 is 0. 2 to the 0 power is 1. If x is 1, y is 0. Log base 2 of 2. 2 to what power is 2? 1. 2 and 1. Log base 2 of 4, that's 2. 4, 2. Okay? So if you look here, it takes me more steps in the x direction than it does in the y direction, so it's slow for me to grow. So in case you forget, just quickly plug it in.
Can you kind of think of it as like a square root graph, or is it dangerous to think of it like that because it's its own thing?
Because square roots only do 2's, but logs can do any exponent. So the right side, sure, there's still like exponents, but they're not the same graph. It follows a different pattern. But if that works for you, that's fine. But the square root graph starts way over here. That's where the square root graph would start. Because the square root of 0 is 0. But we can't take the square root of, there is no log of 0. This doesn't exist. Because no exponent of anything can give you back to 0. Okay? But it does have that similar shape, yes. Okay, Sophia, are you good with this one? Okay. So I think for this one, maybe if you just went through it, x squared, nope, that goes up. This goes up. This goes down. This is up to down. And then so it had to be this one. So you didn't have to check it, but it was the premise, that's what it was, if you didn't know it already. And it's fine. If you don't know it, the calculus exam, you can figure it out. Oh, sorry, that was Jessica. So Jessica, are you cool with that? Were you okay with that one?
Yeah.
Okay. Oh man, this looks crazy. So f prime is continuous on the function of f. Okay, so f prime is continuous. Great, thank you for telling me that. For all real numbers of x, then what is the limit as x approaches 0 of this craziness here? Okay. Now, does this look familiar to you? If I rewrite this as the limit, so I'm trying to take some big ideas here, because oftentimes you might see an equation that looks kind of new, like what in the crap, what is that supposed to mean? And what is that supposed to mean? So I'm looking here, I'm thinking, okay, maybe if I rewrite it as integral a plus h f prime of x dx over h limit as h gets closer to 0. This, it's like, I'm trying to think of like a way to explain it. Like if h is 0, isn't this pretty much 0 on top and then 0 on bottom? 0, 0. Okay. So if it's 0 over 0, we have a trick to try to solve this. And the trick is L'Hopital's rule. If you remember, L'Hopital's rule is if you go ahead and plug in the numbers and it's 0 over 0 or infinity over infinity, we can try L'Hopital's rule. So let's try L'Hopital's rule here. L'Hopital's rule says take the derivative then of the top and the bottom, okay? We're gonna take the derivative of the top and bottom. And wait, with respect to, oh, wait, whoops, sorry. Wait, can we do that? Yeah, sure. With h here, let's do it with h. Okay, that becomes 1 on the bottom. And what happens when I take the derivative of this guy? D over dh, integral of a plus h, f prime of x dx. If you remember, this is our fundamental theorem, so we just plug it in. So we end up with capital F of a plus h over 1. And then take the limit, h gets closer to 0 again. When I do this, if I plug in 0, we have f prime of a over 1. And that is a valid answer. Seem a little terrible? It's okay. See, so what happens is when I see a problem I don't know what to do with, I just play with it. I rewrote it. And I say, hey, what if I did plug in 0? If I did plug in 0, we would end up with 0 with 0. And that's one of our cool things, that if it's 0 with 0, we can do L'Hopital's rule. And L'Hopital's rule just says, hey, take the derivative. And when I took the derivative, this part nicely canceled out and let me plug it in. And we came up with this nice equation instead. Once we have L'Hopital's rule, so be careful if you have a limit as we approach 0 or something, maybe that's L'Hopital's rule, or any value if you get 0 over 0, infinity over infinity, then you can take the derivative and then try again. Okay. But you know what? This formula here does look like rise over run. Kind of, a little bit, right? How much of your f have you changed over a run? But whatever. That's just kind of in the back of my mind. Okay. Any other questions for you guys right now? Okay, 11. Let's do 11. Okay, I need to talk about FRQs today too. Today you guys are doing 4 FRQs, and I'll tell you guys how to submit those FRQs. In the function f given by f, okay, this f of x equals to x cubed has an average value, average of 9 on the closed interval from 0 to k. Okay, f has an average value. The average value function is from a to b, 1 over b minus a of f of x dx. Is everyone okay? That's my equation for average value. They tell me my average value is now equal to 9. If the function of f is given by that has average value of 9 on the closer, what is k? All right, let's fill this out. So 1 over k minus 0, which is just k, integral from 0 to k of f of x, which is x cubed, dx is equal to 9, okay? We can go ahead and then manually solve this. 1 over k. I'm going to actually move k to the other side. So, and if I take the integral, this is 9k over here. The integral of this is x to the 4 over 4, plug in 0 to k. 0 is not going to matter, so let's just keep k. K to the 4th over 4, if you want minus 0 if you want, 9k. And then we are left with k to the 4th is equal to 9k, multiply 4 to both sides. We have k to the 4th equals to 36k. And then, let me check that messed up anywhere. Source number. Okay. If actually, you know, we can divide the k right over. So it's k cubed equals to 36. And then we can cube root both sides. In this case, k is 36, 1 over 3. So the calculus part was this step here, and then algebra 2 the rest of the way.
I read it average rate instead of average value. So
Yeah, see, word. Yeah. So please, when you get your first job, don't think it's like 4,000 versus 40,000. Okay. Okay, what else can I help you guys out with in case you guys get stuck on any other questions? So was this slightly easier than the first time you saw our multiple choice questions? Slightly easier? Just slightly, right? Some of the words seem more familiar. And that's why we're practicing these, is because if you guys study for the SATs, you realize the question and the phrasing start to repeat themselves and you start getting used to it. So you guys can know what to do instead of going, I've never seen that before. And it's true. If you've never seen it before, it's hard to like detangle what they're trying to ask for. But for this problem, they gave me everything I needed, average value. They gave me my interval, right? And they give you everything you need for these questions. Just sometimes there's a little trick to catch it. Okay. All right. Does anyone have any other questions you want me to cover?